In this video, I want to talk about graphing other trigonometric functions, spec specifically graphing tangent and cotangent. Again, like what we said for graphing sine and cosine, the easiest way and um, the first method that we learn for graphing any function is just creating a table value. And we can plug in some point for the x, which are angles, and then find the y value, which is the tangent of those angles. And then we start graphing the function by plotting the points and connecting to each other. Something that is different for graphing tangent than sine and cosine is that for tangent, we can rewrite the tangent as a fraction of sine over cosine. And we know that every time we have a fraction, the denominator cannot be zero. So if I replace a number or an angle for x, which makes the denominator of this fraction zero, it means the tangent is undefined at that or those points. Like pi over 2, as you see on the table, if you replace the x by pi over 2, the cosine of pi over 2 is 0, which means the tangent is undefined. So what happens when we get undefined as a y value? It means those points cannot be in the domain. If those points are not in the domain, they are the vertical asymptote of the tangent function. So for tangent and cotangent, as we can write them as a fraction, tangent is sine over cosine and cotangent is cosine over sine, we always have asymptotes, vertical asymptotes. And vertical asymptotes are a vertical line that passes through those points, the points that cannot be in the domain. For tangent, I know that the pi over 2 cannot be in the domain because any point that makes the cosine 0, the tangent is undefined at those points, like pi over 2. Cosine is 0 at this point, so that can be a vertical asymptote for the tangent function. And also this point, 3 pi over 2. 3 pi over 2 is a point that the cosine is 0 at that point and makes the denominator 0 and tell us that the tangent is undefined. So we can have another asymptote at 3 pi over 2. So the vertical asymptote are the lines that the graph never touch and cross those lines. So that's important that anytime you start graphing tangent and cotangent function, you graph asymptotes first. When you graph asymptotes, it tells you that your graph is not going to touch or cross this line. And as you see in this graph, the function is getting closer and closer to the asymptote, but never touch or cross because it's undefined at those points. And we always graph the function for one period. And one period of the function, it's exactly the distance from the between the two asymptotes. So we know that the pi over 2 is one vertical asymptote, 3 pi over 2 is one vertical asymptote, and in negative direction, negative pi over 2 is also a vertical asymptote. So that's why we usually graph the tangent function from negative pi over 2 to positive pi over 2. And if we want to talk about the properties of the tangent function, we know that the period of the tangent and cotangent, both of those functions, is pi. And tangent is like a sine function, is an odd function, and all odd functions are symmetric about the origin. And as I mentioned, since the tangent is undefined, and for example, pi over 2 or negative pi over 2, those points are the vertical asymptote. So the tangent has a vertical asymptote at those points. And those points cannot be on the domain, and we call them the odd multiples of pi over 2. Why? Because if you look at the unit circle, you say that that's a cosine function. And you say the cosine function is 0 at this point, which is 1 pi over 2, is also 0 at this pi over 2, which is 3 pi over 2. If I pass one rotation, I get back to this point, I will have a 5 pi over 2. And then if I move to this point, I will get 7 pi over 2. And it tells me that all the multiples of pi over 2, all are the asymptotes. Like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, or in negative direction, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. And if we extend the graph, extend the tangent graph, we can have all of them and we can see them on this picture. And we have a repeated shape between the two asymptotes. Like sine and cosine, we always graph the function for one period and then we extend it if we want to graph it over one period as well. But the range of the tangent function is all real numbers. That means you can have any number for tangent and cotangent. It's not the same as the sine and cosine. For sine and cosine, because they are in a unit circle, they are limited. So the sine and cosine are always between -1 to 1. But for tangent, cotangent, we don't have any limits. So for the range or for the y value or for the tangent of any angle, we can get any numbers. So that's why we say the range is all real numbers. And you can also see in the graph, in this picture, that the y value, it's just going up all the way to infinity and going down all the way to negative infinity. That's why the range is all real numbers or from negative infinity to positive infinity. So I mentioned the vertical asymptotes are odd multiples of pi over 2. Those are the exact point that they are not in the domain. If you want to find the x-intercept, you only need to find the midway between the two consecutive asymptotes, which is this point. If you look at this asymptote and this asymptote, the x-intercept is the midway between the two asymptotes. And for graphing the function, beside finding the x-intercept, which is the midway, we also need to find two other points, which we call them 1/4 and 3/4. Because we want the distance between the two asymptotes be divided into 4 equal parts. So we need 1, 2, 4, 3, and 4 equal parts. That's why, so after graphing the asymptotes, we find the midway. After finding the midway, we find the 1/4 and 3/4, which is the midway between the midpoint and each of those asymptotes. And to find the y value of those 2 points, we always have a rule that the y value of those 2 points are -1 and 1. Because in this function, a is 1. When you have y equal tangent of x, that means a is 1. And the y value of those 2 points are -1 and +1. But if a is any other points, the y value of those 2 points are -a and +a. Now the question is how we can find asymptotes. So to find the asymptotes, we always set whatever we have inside of the parenthesis in front of the tangent, we set it equal to -pi/2 and +pi/2. Because in tangent function, pi/2 and -pi/2 are always asymptotes. But even if we have numbers in front of the x, like we have bx minus c, we have to set that whole thing equal to -pi/2 and +pi/2. And then we simplify this one and find the x. And after finding the x, we get the equations of the asymptotes. And after finding the equation of the asymptotes, we graph them. And then to find the x-intercept, we find the midway between the two asymptotes. After finding the x-intercept, we will find two other points, which is 1/4 and 3/4 of that, the distance between the asymptotes. And those 2 points have the y value of -a and +a, so we don't need to calculate them like what we did in the sine and cosine, because they're usually -a and +a. And then we plot all the points and graph the function for one period of the function. So these are the steps that we follow, and I want to show you an example that how it works. And you can see better in this picture as well. That is the x-intercept, 1/4 and 3/4. And the y value of the 1/4 is always negative a. The y value of 3/4 is always positive a. When we say 1/4 and 3/4 means one-fourth of the distance between the two asymptotes, or 3/4 of the distance between the two asymptotes. Let's look at this example. We want to graph y equals 3 tangent of 2x for all the x values that are between negative pi over 2 and negative pi over 4 and 3 pi over 4. So first step, what is a and what is b in this equation? So the a is 3 and the b is 2. If they ask you to find the period of this function, you know that the period of all time tangent function are pi over b. And if I want to find the period of this function, it's pi over 2, which means the distance between the two asymptotes is pi over 2. But unlike the sine and cosine, we don't need the period of the function because we need to find asymptotes first. How do we find asymptotes? By set the function, set the equation, set whatever we have in front of the tangent, which is 2x in this example, we set it equal to negative pi over 2 and positive pi over 2. Okay, so if we set it equal to pi over 2, if 2x is equal to pi over 2, to find the x, we just need to divide both sides by 2. So we get x, which is equal to pi over 4. If you set it equal to negative pi over 2 and divide both sides by 2, you get x equal negative pi over 4. These are the equation of the vertical asymptotes. Next step, we need to find the midway. If you want to graph this function right now, you have these points, negative pi over 4 as the first vertical asymptote and positive pi over 4 as your second vertical asymptote. And you want to find the midway. And as you see, the midway between these 2 points is exactly the origin. Okay. How you can find the midway between the 2 points? Every time you want to find a midpoint between the 2 other points, you can easily, even if you don't have a graph, you can easily add the numbers and divide by 4. You can easily divide pi over 4 and negative pi over 4 and then add them and divide it by 2. And you know that the 0 over 2 is always 0. That's why you can also see in this coordinate plane that the midway is 0 and 0. Then we need to find the 1/4 and 3/4. 1/4 is halfway between the origin and these asymptotes, and 3/4 is the halfway between these two. Where is the halfway between the 0 and negative pi over 4? Again, you can add them and divide by 2. Okay? So you can add 0 by negative pi over 4 and then divide it by 2, which tells you negative pi over 4 divided by 2, and it's negative pi over 8. And the other point is 0 plus pi over 4 divided by 2, which is positive pi over 8. There is another way of finding those points, which I show on this slide. But if you do like me, just by finding, by graphing like this, graphing in the coordinate plane, and by looking at the point and add them, divide by 2, find the point is much easier than this method. In this method, it tells you that we know that the y coordinate of those 2 points is always negative a and positive a. And since in this equation, the a is 3, we know that those 2 points, these 2 points, the coordinate of these 2 points, one of them is negative 3 and the other one is positive 3. And to find the points, they are going to set the equation equal to -3 and set the equation to +3. And then try to solve the equation to find the x. And you see that we get pi/8 and -pi/8. But if you graph it and do the same as mine, just by looking at the point and add them, divide by 2, is much easier than solving these two equations. But it's up to you which method you want to use. And you know that the y value of this point, which is 1/4, is -a. The y value of this point, which is 3/4, because we always look at the graph from left to right, that's +a. So we have two other points which are -pi/8 and -3, and +pi/8 and +3. Now it's time to plot all these points and then graph them. And you can see from -pi to pi/2, the midway is 0 and 0. Halfway is -pi/4 and +pi/4. And that's exactly -3 and +3. And now we have this graph, this part. But that's the graph only for one period of the function. If you remember at the beginning of the question, it was asking us that you graph the function from -pi/4 to 3pi/4. But right now, you have it from -pi/4 to +pi/4. So it means that we need to graph the function for two periods of the function. But from -pi/4 to +pi/4, we have it just over one period. So we extend the graph, and we know 3pi/4 is another asymptote. We graph the asymptote, and exactly the same as this part of the graph that we already graphed it, we just find the midpoint, midpoint with -3, midpoint with +3, and then graph the other part. Let's look at this example. Okay. We want to graph y equal tangent of x plus pi/4. Okay, first of all, we need to know what's a, what's b, and what is c. A is the number that's here, it's 1. B is the number in front of the x, which is 1. And c is the number that's inside the parentheses, adding or subtracting by x, which is -pi/4 in this example. When we have a c, it means we have a phase shift. And you can imagine that the graph will be shifted to the left. So your midpoint is not 0 and 0 anymore, for sure. Okay, now let's see how we can find all those points. First step, we need to find asymptotes. To find asymptotes, we need everything inside the parenthesis, x plus pi/4, set it equal to -pi/2 and +pi/2. And we have two equations to solve. If I solve this one, to solve and find the x, I need to subtract pi/4 from the both sides. So I get x equal -pi/2 minus pi/4. And if I find the common denominator, I get -3pi/4. That's my first asymptote. And for the other equation, if I subtract pi/4 from the both sides, I get x equal pi/2 minus pi/4. And if I find the common denominator, I get x equal pi/4. That's my second asymptote. And if I want to graph this function for one period, I need to graph it from -3pi/4 to +pi/4. So I prefer to graph the asymptotes because it gives me a better observation of the points, and finding the points is much easier in that way. Okay. Pi/4. It's on the positive direction. And if this is 1pi/4, the other in negative direction, I need 3pi/4, which means 3 times of this distance. So 1, 2, and 3. So that's -3pi/4. And as you see, the Distance between the two asymptotes is divided to 4 equal parts. And if I want to find the midway for the x-intercept, it's easy to find it from the graph because I know this is negative 1 pi over 4 and this one is negative 2 pi over 4. Okay, so the midway is a midpoint from negative 3 pi over 4 and pi over 4. If you can't find the point from the graph, you can easily add the two asymptotes and then divide it by 2. And if you add these two, you get negative 2 pi over 4. And if you divide it by 2, you get negative 2 pi over 8, and which is negative pi over 4. And you can see that we have negative pi over 4 here. Now it's time to find the 1/4 and 3/4, which is this point and this point. But if you graph it, you can easily find the point from the graph. If you don't have the graph, just find the midpoint between negative pi over 4 and negative 3 pi over 4. And if you add negative pi over 4 by negative 3 pi over 4 and then divide it by 2, you get negative 4 pi over 4, which is negative pi, and then divide by 2, which is negative pi over 2. And if you simplify this point, it's exactly negative pi over 2. And for the other point, I need the midpoint between negative pi over 4 and positive pi over 4, which is exactly 0. So now we have all 3 points between the asymptotes. Now it's time to find them. Excuse me. It's time to find the y value of these points. This time, unlike the sine and cosine, we don't need to calculate because we know that the y value of the first point is negative a, which is negative 1 in this example. So we have a negative pi over 2 and negative 1. And the y value of the 3/4, which is 0, is positive a, which is positive 1. Let me show all the points. Again, let me just clean this part. That's negative pi over 2, negative pi over 2 and negative 1. That's my first point. 0 and positive 1, it's another point. And now I can graph the function. So make sure that you're not touching the asymptotes, but you're getting close to asymptotes and going up on the right side, getting close to asymptotes and going down on the left side. And that's a graph for one period of the function. But if they ask us you graph it for 2 periods, you need to extend it into the right or to the left based on what they are asking for. So the graph of cotangent is also similar to the tangent. For cotangent, as the cotangent also is cosine over sine, we will have asymptotes. But the difference here is that for the cotangent, the denominators are sine, and the asymptotes are the points that make the sine 0. So where is the sine equal to 0? If that's a unit circle, and you know that's a sine, sine is 0 at this point, which is 0, this point, which is pi, this point again, after one rotation, is 2 pi, this point, which is 3 pi, another rotation, which is 3 pi, 4 pi, sorry, and then another one, which is 5 pi, 6 pi, 7 pi, 8 pi. So all multiples of pi can be the asymptotes because the sine is 0 in all of those points. So this time you can see the asymptotes. 0, which means the y-axis, pi, 2 pi, 3 pi, 4 pi, and in negative direction we have negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So all integer multiples of pi can be the asymptotes. The period of cotangent is like cotangent is pi, And if you want to find the period of the function which has a number, it's pi over b. And the range, again, is all real numbers. We can get any number for cotangent. So the x-intercept, again, is the midway between the two consecutive asymptotes. So we find the 1/4 and 3/4. And we know that the y-axis for 1/4 and negative and 3/4 are this time are 1 and -1. So for tangent, we say 1/4 and 3/4. For tangent, we say -1 and 1. But for cotangent, we say 1 and -1. And that's the only difference, one of the difference between the tangent and cotangent, because the tangent is always like that, but the cotangent is like that. It's in something. So to find asymptotes in tangent, if you remember, we set everything that was in front of the tangent, which is bx minus c, we set it equal to -pi/2 and pi/2. But for cotangent, we set it equal to 0 and pi. After finding the asymptotes, we find the x-intercept, which is the midpoint, and then we find the 1/4 and 3/4, which are the midpoint between the x-intercept and each of those asymptotes. And we know that the y value of those 2 points are positive a and negative a. And then we graph the cotangent. Let's look at an example. We want to graph these functions. 1/2 of the cotangent of pi over 2x. So first of all, let's see what's a, what's b, and what is c. So a is 1/2, b is pi over 2. There is no c, which means the c is 0. When c is 0, that means we don't have a phase shift. Okay. First of all, we need to find asymptotes. And to find asymptotes, everything that's in front of the cotangent, which is right now is pi over 2x, must be set it equal to 0 and pi. So if we set pi over 2x equal to 0, and you want to solve for x, you need to divide both sides by pi over 2. And if you divide 0 by any number, you just get 0. So that's one of your asymptotes. You also need to set it equal to pi. Again, to solve this equation, you need to divide both sides by pi over 2. And I know that the pi divide by pi over 2, by keep, flip, and change, I get pi and pi cancel each other, and I get x equal 2. So the asymptotes are x equals 0 and x equal 2. After finding the asymptotes in first step, we need to find the x-intercept, which is a midpoint between these 2 points. And if you want to graph this function, if I want to show you in a graph, x equals 0, it's the y-axis, and x equals 2, that's this point. And you can easily, by the graph, can see the midpoint. Midpoint, that's exactly a point between the two asymptotes. And what is the point between 0 and 2? It's x equal 1. So x equal 1, that's your x-intercept. Then, step 3, we need to find 1/4 and 3/4. So let me graph it again. So one of the asymptotes is x equals 0. The other asymptote is x equal 2. And you know the midpoint or the x-intercept is 1 and 0. Now I want to, that's 1. I want these 2 points. What's the midpoint between 0 and 1? Just add 0 by 1 and divide by 2, which is 1/2. What's the midpoint between 1 and 2? Add 1 by 2 and then divide it by 2, which is 3/2. After finding these 2 points, you know that the y value for these points are a and negative a. And the a in this equation is 1/2. Okay. So 1/2 is the a, which is the positive is for the first one and negative for the second point. So now I can graph the function, which is something like this. You can also find those 2 points by solving the equation and by setting the whole equation by negative 1/2 and positive 1/2, which are the a and negative a. Now we graph the function, and you can see the graph here. And this is an extra. This is when we need to extend, but right now we don't need to extend the function. I don't think they asked us in the beginning. Okay. Next example, we want to graph 2 periods of this function. Okay, let's graph it for 1 period and then extend it for 2 periods. First of all, what is A? A is 4. What is B? Which is pi over 8. What is C? It's pi over 2. And what is D is negative 2. So based on the numbers for A, B, C, D, I can see that this graph has a vertical shift and also a phase shift. Now it's time to find the asymptotes. To find the asymptote, anything that's inside the parenthesis, which is pi over 8x minus pi over 2, you must set this one, let me just write it 2 times. You need to set it equal to 0 and equal to pi, because that's a cotangent function. And then try to solve for x. Solve for x means isolate the x. The first step to isolate the x is just adding by pi over 2, adding pi over 2 to the both sides. So we get pi over 8x, which is equal to pi over 2. And then divide both sides by pi over 8. And if you divide pi over 2 by pi over 8, after keep flip change, I get 4. So x equal 4, that's my first asymptote. We do the same for the other one. We add pi over 2 first to the both sides. And we get pi over 8x, which is equal to 1 pi plus pi over 2, which is 3 pi over 2. Then we need to divide both sides by pi over 8. And if you divide 3 pi over 2 by pi over 8, we get, don't forget to do the keep flip change, we get x equal 12. These are my 2 asymptotes. I want to start graphing right now. So x equal 4, 1, 2, 3, 4. Let's graph the first asymptote. And 12. 5, 6, 7, 8, 9, 10, 11, 12. These are the asymptotes. Step 2 is finding the x-intercept, which is the midpoint between 4 and 12. And the distance between 4 and 12 is 8, and half of the 8 is 4. And 4 plus 4 is 8. So 1, 2, 3, 4. So that's a midpoint, which is 8. Or you can add 4 by 12 and then divide it by 2. That's your x-intercept. But we know that we have a vertical shift here. When we have a vertical shift, it means that the midpoint, it may not be on the x-axis anymore, because the center line also will be shifted 2 down. So to find that, let's replace this point for x and see what do we get. So it's better not to put any point right now. If I replace the x by 8, I get y, which is equal to 4 cotangent of pi over 8 times 8 minus pi over 2, and then minus 2. If they cancel each other, you have pi minus pi over 2 inside the parenthesis, which the answer is pi over 2 again. And you need to find the cotangent of pi over 2. And the cotangent of pi over 2 is, it's cosine over sine, which is 0. And 0 times 4, it's 0. 0 minus 2 is negative 2. So instead of having a point on the x-axis, since we have vertical shift, the point will be shifted 2 down because we have vertical shift. So you have to pay attention, especially when you have vertical shift. Then we need to find the 1/4 and 3/4 point, which is a point between 4 and 8. And I can see it here. That's this point and this point. That's exactly the midpoint between 4 and 8. 4 plus 8 is 12, divided by 2 is 6. 8 plus 12 is 20, divided by 2 is 10. And I need to find the y values of these points. So I know that the y value of this point must be positive a, and this point must be negative a, if I don't have a vertical shift. But if you have a vertical shift, you need to consider the vertical shift as well. So what is positive a minus 2? A is 4. What is positive 4 minus 2? Which is 2. What is negative 4 minus 2? Which is negative 6. So don't forget, if you have vertical shift, you need to consider the vertical shift, but adding and subtracting by a. And negative 6, let me just erase this part. 2, 3, 4, 5, 6. And that's the point. Now I can graph the function, and don't forget that these are not the points. These are just how we show the 1/4 and 3/4 point. These are my points. So I'm not touching the asymptotes. Make a smooth curve. And as you know that when we have a tangent and cotangent function, this a is not called an amplitude anymore, because the function, tangent, cotangent function, always just going all the way to infinity. Instead of calling them amplitude, we call a the vertical stretch. Vertical stretch means how much your graph will be stretched going up or down. And you can see in this graph, since the a is 4, it's a big number, my graph is just getting a stretch, and it's getting, kind of close to a straight line instead of having a curve because of that stretch.